Alright, thought it'd be good if we could go through and do some examples. I did examples of conjugates in class. Remember that this process, so these examples that you do in class, this particular permutation has the cycle structure up front, down front, and then back again, and upright, down right, and back again. It has a pair of 2 cycles. Conjugates preserve 2 cycles. And so I want to do some examples of this. And the idea is to achieve some other pair of 2 cycles. So maybe I want something like this. This is just an exercise. So how would I get this effect from this permutation? Well, I do a conjugate of it. I keep that permutation, and then I try to find a way to make this work. So here's how that's going to happen. I'm going to do an F and Fi and show you why that works. So here's our cube. Now this original permutation affects these 2 pieces and these 2 pieces. It doesn't affect the red and yellow, it affects whatever is in the up front. So if I put some different pieces there, so that's F, I've just placed this red-blue up front and this blue-green down front. If I now do this permutation, it's going to swap these 2 pieces. So let's do it and see. F squared, R squared, F squared, R squared, F squared, R squared. And then I undo my setup, Fi. And so this is a conjugate because I have a setup, and then I have undo the setup. And well, what's happened? Well, I have the upright and the downright, those changed as before. But now I have the front right and the front left are changing. So I have upright, down right, and back again. Now I have front right, front left. It's still a pair of 2 cycles, but it's a different pair of 2 cycles. Conjugates will always have the same cycle structure as the original permutation. Different locations, but the same number of cycles and types of cycles. Because this permutation is its own inverse, so will this. So I'll just do this again. F, and then F squared, R squared, F squared, R squared, F squared, R squared, Fi. Let's try another one. Suppose I wanted to swap the front right and back right, but to keep the up front and down front. So this is my goal, up front to down front, and then front right to back right. So here's what I'm going to do. I'm going to use this same permutation as the core, if you will, and then I'm going to do an R and an Ri. Now watch what that does. As I do an R, what's happening, these 2 pieces that I want to swap, I'm putting in place. They're going to get swapped when I do this permutation. This permutation affects locations, not particular pieces. It's whatever pieces we place in those locations. Let's try it. F squared, R squared, F squared, R squared, F squared, R squared, Ri. Now you can see there's my up front and down front, and here's my front right and back right. So it accomplished it. And again, if we want to undo this, we just do it again. So R, F squared, R squared, F squared, R squared, F squared, R squared, Ri. Now we can do things that are a bit more complicated, a bit more challenging. Suppose I wanted all of my swaps to happen on one face. That is, I want something like this. So somehow I have to use whatever this original permutation did. The original permutation affects these pieces or locations, but also this. So I have to use that somehow. So one way of doing this, there's a bunch of different ways, might be to move these two pieces that I want to swap over to the side. Right? So now if I did the permutation, these two would swap. That's good. So what did I just do there? Well, I did a U, I, and a D. But I also want to swap the front right and left right. If I want to swap them, they have to be in the up front, down front position. So then I could do something like an F. Right. Now this is my setup. So to keep this as a conjugate, I need to undo my setup. I need the inverse. So that would be Fi, Di, U. Now let's just try it and see what happens. So I've done the setup. Now I'll do F squared, R squared, F squared, R squared, F squared, R squared. And then I do the inverse, which is Fi, Di, and U. And then what happened? Well, there's my up front and down front. They swapped. And then my front right and left and the front left, they swapped. So I accomplished it. I'm moving all sorts of pairs of pieces. So up front to down front, and then front right to front left. I'm changing which pair of edges are being swapped using this conjugate process. And again, to undo this, because this is a really nice permutation, it's its own inverse. If I just do this again, it'll be fine. So I'll do UI, D, F, and then I'll do my F squared, R squared, F squared, R squared, F squared, R squared, and then Fi, Di, and U, and I'm back. So you might want to try making up some other conjugates, and it's really easy to do this. You don't even have to have a goal in mind. All you have to do is do a setup, and then the inverse of the setup. So you can try some experiments and see where you can put these corners or these edges. Can you swap the front two pair and then the back two? Can you swap sort of adjacent edges? There are various puzzles that you could, sort of pieces of these puzzles you could solve by playing with permutation. So I'll stop there.